This is Sarah Wilkinson from Humber College and the University of Guelph-Humber. In this next video, I'll be going over the second factor that affects stroke volume, that is contractility. I've already covered a definition of cardiac output, stroke volume, and heart rate, discussed heart rate's regulation, and in the first part of the stroke volume series, discussed what preload is and the factors that affect it. Let's look at contractility. Before we do that, recall that stroke volume is the volume of blood ejected from the heart ventricle with each beat. One of the key factors that's going to affect how much blood is pumped from the heart is the ability of the myocardium to produce force. Recall that the myocardium is the muscle of the heart. There are a couple factors that are going to affect how much force this muscle produces. One is the size or the quality. So if you have a large myocardium, or if the myocardium is very strong, you're going to be able to produce more force. And I'll discuss this a bit more in a second. And the second main factor that's going to affect the force produced is the ability of myosin to bind to actin. And recall these are the two contractile proteins. And I'll go over that secondly. Let's take a closer look at the size of the myocardium. On this graph here, I have on the x-axis two different populations. So a population that's sedentary, does not regularly perform endurance activity, and the second is endurance athlete. And on the y-axis is heart volume. And so what we know is for an average sedentary man, so our average Joe, his heart would hold about 750 milliliters. Whereas for endurance athlete, they have much larger hearts and hence a much larger myocardium. So much bigger hearts holding more blood and greater ability to contract that myocardium. Endurance athletes have a stronger heart muscle because they're using it more often. And so therefore, one of the reasons they have a larger stroke volume is a larger heart muscle. Now, this isn't the main factor that actually affects stroke volume in endurance athletes. You'll learn that it's actually their blood volume, so hence their preload. And we'll discuss that more in class. Let's look a little bit closer at the ability of our two contractile proteins to bind with one another. Recall that myosin can only bind to actin if the active site is not blocked by tropomyosin. So let's look at a picture of this. The green dots, these green dots represent our actin protein, and the darker green dots here is what's called the active site, and that's what myosin heads are going to bind to. And this yellow line here is another protein called tropomyosin. And so when an action potential arrives in the cell, and I've got some videos on this if you'd like to learn a bit more about that, calcium will be released from the sarcoplasmic reticulum. And when this calcium binds to another protein, troponin molecules are going to move the tropomyosin. So this moves the tropomyosin off the active site of actin. So now we have our active sites exposed so that myosin, which is this large protein, can now bind and initiate a power stroke. Therefore, if we have more intracellular calcium, there's going to be more ability of myosin to bind to actin, and when more myosin binds to actin, there's a more forceful contraction. So what's going to determine how much intracellular calcium there is? Recall that it's the action potential arriving at the cell that causes the release of calcium. So if there's more frequent action potentials, there'll be more intracellular calcium. And what determines the frequency of action potentials is sympathetic nervous system activation. Recall from my previous video, the sympathetic cardiac nerve innervates both the SA and AV node, which is going to affect the speed of contraction, so heart rate. In addition, it also innervates directly the myocardium. This is going to affect the concentration of calcium within the cell, and more calcium, stronger contraction. So when the cardiac nerve is stimulated, not only will the heart beat faster, it will also contract with greater force. So to add to our flow chart, what causes more intracellular calcium is a greater sympathetic stimulation. And so during exercise, we see a greater sympathetic stimulation of the myocardium and an increased contractility, hence a higher stroke volume. To recap, contractility is the ability of the myocardium, the heart muscle, to produce force, and it's going to depend on the size or quality of the myocardium. So is this a large heart muscle of an endurance athlete or one that is less well trained? And secondly, it's going to depend on changes in intracellular calcium, which will affect the contractile proteins binding to one another. In the next video, I'll discuss the third factor that affects stroke volume, and that is afterload.